Hello and welcome to the tutorial video for tracing function calls and applications with AQtime Pro. Often, developers encounter a situation when an application crashes and don't know the cause. So in order to understand what's going on during the run, the first thing you need to do is look at a call stack. The call stack provides a list of the method calls leading up to the current point of execution. However, the call stack does not reflect how the program got to that point, except by tracking function calls. And so to analyze the application's behavior completely, you also need to know how long the functions took to execute, what arguments those functions got called with, what the return values were, and so on. Now to get this information, you can add function trace calls to your application's code. And that additional code would log the call stack, error trace, parameter values, and so on. And then when the traceable application is run, it does whatever the original app did, plus these additional tracing operations. However, adding tracing code is a time-consuming task, and it makes the application much larger. A different way to trace function calls is to use a special function trace profiler provided by AQtime Pro. This profiler does not require you to modify your source code in any way, shape, or form. It automatically gathers information about the executing functions in your program. This profiler helps you trace the exact sequence of function calls in your code. It provides you with comprehensive information about each application function, the different routes used to invoke the application, the exact parameter values passed to each call, the return values, and so on. So let's see how you can use the function trace profiler to analyze your application. In our demonstration today, we're going to use a sample Delphi application that connects to a COM server and calls that server's function, and that COM server was written in Visual C++. Now, since we're dealing with code compiled with different compilers, it will be difficult to trace the function calls in the case of an application crash. Visual Studio is unable to trace Object Pascal code, and vice versa, Delphi doesn't support tracing C++. So, to search for problems in our application, we'll profile it with AQtime Pro because it supports profiling code compiled with different development tools. Okay, so the first thing we need to do is create a new profiling project for our application. So to do this, I'm going to click the Create a New Project from Module button here on AQtime's Start page. That's going to pop up this Open File dialog, and I'm just going to browse out to where my application lives. Okay, so there's my sample application. I'll click Open. And now AQtime creates a profiling project and adds that application to the Modules pane right here. Now, in order for AQtime to be able to profile the functions of the COM server that's being called by our application, we also need to add that COM server's module to our profiling project. So to do that, I'm going to right-click inside the Modules node here and select Add Module from the right-click menu. Then I'm going to browse to where my module lives. In this case, it's in this sample server DLL. I'll select that, click Open. And now you can see that AQtime has added that module to the project. So now to check the performance of our application, I'm going to profile it with the Performance Profiler. So I'm just going to come up here to the Profiler's toolbar, and I'm going to select Performance Profiler. And then I'll click the Run button to start the profiling process. So AQtime has launched my application, and now I'm going to click Execute. And what's happening is the application is connecting to the COM server behind the scenes and calling its functions. So now I'm going to close the application, and AQtime is going to generate some profiling results and display them here on this report panel. Okay, so let's take a look at our results. For starters, I'm going to sort my results on this Time with Children column right here. And Time with Children shows the total time spent on calls to a routine, including the child routines that routine may call. So according to the data displayed in the Time with Children column, the slowest profiled routine is this guy right here, Execute Button Click. And that's expected because this routine makes up the main part of the application. So to see what functions this particular routine calls, I'm going to switch over to the Call Graph panel right here. And we'll make this panel a little bit bigger so that we can see more of the tree. Okay, now the Call Graph panel displays a hierarchy of function calls in graphical format. And we can see here that the Execute Button Click function right here calls all these functions right here. So we call the test method, and then we call do action A, do action B, etc. So it's calling all those functions. Now looking across, you can see that do action A calls the COM server test method. Do action B, if we follow that, calls do action B1, and then that calls the COM server test method. And then we're calling do action C, which calls do action C1, do action C2, and ultimately calls the COM server test method. So from what we can see in this panel is that COM server test method is being called from 4 different functions. And then each function calls that test method a different number of times. And the hit count number shown right here inside this rectangle is telling us that this function was called 41 times. You can see right here that the doActionA function is calling it 21 times. DoActionB1 is calling it 31 times. DoActionC2 is calling it 41 times. Now, the time with children value specifies the total time spent on the COM server to test method. You can see that right here. Now, the time with children value specifies the total time spent on calls to the COM server test method. You can see over here, to do the 21 calls that doActionA made took about 2,700 microseconds. Right here, the 41 calls took about 2,600 microseconds. So what's the matter with this? Well, let's view that subfunction's source code. And to do that, I'm just going to switch over to the editor panel here. And this test function, what it's basically doing is checking to see if a number is odd or even. The checked number is passed to it as a parameter. And if the number is even, the function returns true, as you can see right here. And if the function is odd, then it returns false. So it's possible that the function execution time depends on the parameter value. So to know how long a function actually executes with a certain parameter value, I'm going to profile our application with the function trace profiler. So the first thing I'm going to do is flip back to the setup panel here, and I'm going to change my profiler from performance to function trace. This profile is going to trace the actual sequence of routine calls and collect timing and hit count information. Additionally, it will gather information on routine parameters, but in order to do this, we need to create a profiling area with certain properties enabled. So to create a new area, I'm going to right-click inside the Areas pane here, and I'm going to choose Add Area. And I'm going to give my area a more descriptive name here. I'm going to call this the Slow Routine Area. And I'm going to profile down at the routine level, and I'm going to choose to retrieve parameter values. Now I'll click OK. And you can see here, I'll make this panel a little bigger, AQtime has added that new area to our setup panel. So now we need to add code to this profiled area. So I'm going to add both the modules to this profiling area. We'll drag in the sample server and the sample app. I'm just dragging those right on top there. And as we've added the modules to the area and not individual functions, that means all the routines inside those modules will be profiled. Now I'm going to disable the full check by routines area here because we don't need that. And I'm going to start profiling by clicking the Run button. Okay, now AQtime is going to pop up this Run Settings dialog, and this dialog allows you to configure a number of settings for the coming profiler run. The only thing we want to modify here is the maximum route depth setting. And this specifies the number of routines that will be traced for each route. Since route tracing consumes a lot of memory, by default this is set to 0, so that means that we're not tracing routes. But to enable tracing, you can put in any number that's greater than 0 for this option. We're going to specify 40. And now I'll click Run. AQtime again is going to launch our profiled application. In the application, I'm going to press the Execute button. The app has performed a series of actions, and now I'm going to close the application down. And now we've got a new set of results to check out. As you can see, AQtime organizes your results into two categories, call trace and routines. The routines category provides information about the functions that were included in the profiling tasks. You can investigate the route calls for the functions. So let's explore the call routes for the COM server test method, which is right here. To do that, I'm just going to select the routine here in the report panel and then switch over to the details pane. And this displays the list of calling routes for the routine and the contents of each route. So as you can see, the COM server test routine has 4 calling routes. They're shown over here in the call routes table. And the route number column, shown right here, displays the route index and the hit count, which indicates how many times the route was used during the application execution. To view the sequence of function calls that make up a certain route, I'll select the desired route in the call routes list, so we'll look at route number 0 here, and then look over here at the call stack pane. And this table contains information about function calls that lead up to the calling of the selected routine. The call number column that you see over here indicates the order of the call, and then the topmost row corresponds to the selected routine. In our case, it's COM server test, and then the second row here refers to the routine that called COM server test. In this case, it's the execute button click routine. So I'm going to double click the execute button click routine, and AQtime brings up the editor panel. And here we can see on this line that we are actually calling that test function
11 times because of this little loop right here that's been implemented. And we see that hold consistent right here with what we saw in the hit count column. If we look at the second item in the list, we can see that the test routine was also called by the doActionA routine. And doActionA was called by the execute button click function. So if we look back at the source code here, we can start here, that's where we're calling doActionA. And if we look inside doActionA's code, we can see that it's calling our test method 21 times. And that holds consistent with what we saw right here inside the details panel. So in doing this, you can explore all the routes in which the test function was called during the application's run. Now, besides tracing the call routes, the function trace profiler measures the duration of function calls and logs the actual values of the function parameters. And to view that, select the call trace category here in the Explorer panel, and then take a look at the report panel. Here you can see the sequence of function calls in the profiled application and some call characteristics. The call number column right here indicates the call index for each routine. The parent name column shows the name of the routine that called the given routine. And then the time and time with children columns show the execution time of the function call. So let's trace the calls to the COM server test function and see how long each function call took. So I'm going to change this to microseconds. And here we can see that the first 11 calls that were made to our test function and how much time they took. You can see that the first two calls that I have highlighted there took about a little over 1,000 microseconds, whereas the rest of them took, 0.1 to 0.12 microsecond. After the execute button click event called the COM server test function for the 11th time, which is right here in row 16, it called the doActionA function. And then the doActionA function called the test method, as we know, 21 more times. And so we can scroll through here to see the execution time of that. And just like what we saw earlier, you notice that the first two calls that got made took significantly longer than the remaining calls. And then the same thing happens when doActionB gets called. We call doActionB, you remember doActionB1 is the one that actually called the test method. And again, the first two calls to that take a long time, but the remaining calls only take, a fraction of that. And the same thing holds true with the doActionC2. So we're seeing the same pattern over and over again. So the first two calls that are made to that test function always take more time than the rest of the function calls. So let's see what parameter values are being passed into those function calls and what the results of those calls are. So to view the list of function parameters, I'm going to select a function call here in the report pane. I'll just pick the very first one, and I'm going to make sure I'm on the details panel. And this panel down here is displaying information on the function parameters that were passed to the routine. In this case, we can see that we had a 0 passed in, and in row 7 we can see that a 1 was passed in. And then the remaining functions, 2, 3, 4, they are running faster. We can see this behavior holds true with the doActionA ones here. At 0 and 1, our execution time is slow, and then when we get down to 2, everything is faster. So for some reason, passing in the values 0 or 1 slows down the execution. So let's dig into that a little bit more. Let's look at this again. Now in looking at this, you can see that we're passing in the value of 0, we're getting back the value of 0. That's the return code here. That means that when we calculated whether or not 0 was odd or even, our function is actually returning 0, which is incorrect. It should be returning that this function is even. What 0 means in this call is that it's returning the number is odd. So 0 is not calculating correctly. And in fact, if we look at the code for this inside of Visual Studio, we can see that this function is using a pretty strange algorithm for determining whether or not number is odd or even. So what we're going to do is fix our code and see if that improves the process. Okay, so let's clean up this code here. I'm going to comment out this code right here because this is really strange. And we're going to put in the following. Okay, so I've just modified the code a bit here, so you can see now we're basically using a modulo to see whether or not we are even or odd. I'm going to save my changes and rebuild my project. Okay, switch back to AQtime, and AQtime will automatically update debug information for the modules. So now I'm going to profile my application again. Just going to click the Run button here. I'm going to keep the same settings that we had earlier and click the Run button. AQtime is going to profile our application. The Execute button, close it down, generate our results, and this time around, in looking at the results, you can see that all the calls to the test method took about the same amount of time. Took to between 0.14 and 0.31 seconds, so much faster than what we had last time around. And if we look at the test results On the details pane here, we can see that when we pass back our parameter here, we can see that we're getting back a -1 now, meaning that we're getting the correct result for the number of 0. So we fixed the error here.
This concludes our video on the Function Trace Profiler. We hope you enjoyed it. If you have any questions, please don't hesitate to contact us at the URL on your screen. We wish you luck and hope you enjoy profiling your applications